How's it going, ladies and gentlemen? We're up to the next episode of Design Patterns, and this one is going to be about the flyweight pattern. Now, what the flyweight pattern is for basically saving memory and space. So essentially, well, let's just go ahead and do an example. I'm going to make a new folder here. We'll call it flyweight, and we're going to bring in, well, we're going to need one of these CMake files, and we're going to make a main to actually run the code at the end when we're done typing it up. And I think that's all we're going to need here. Let's rename these. Let's actually start out with the front end code here and kind of walk through it. So essentially, if you're reusing an object that maybe has some properties, sometimes you don't want to reinstantiate that object over and over, and in that case you would just keep referring to the same one and maybe apply some properties over it if you need to, such as, well, for in a game, let's think about, what if you want to place a bunch of grass on the ground, but you don't want it to like overload all your processes. It's like processing all this grass just killed my frame rates type of thing. You don't want that to happen. So in games, this is often used for terrain, repeating grass, repeating bushes, stuff like that. But it could really apply to anything that has a lot of shared properties. All right, so let's just dive in here real quick. Let's make an int main, and let's say that we want to make a world of random grass. And for, in a real generator thing, it might be a little better. We're just gonna like make a big block of grass. So we'll just make like a 10 by 10 of little grasses. Little grasses. That sounds funny. Int I. So we'll just do this simple pattern to go 10 deep, and we'll put another loop in that. So just straightforward little loop there. And in here, we'll just place grass. So we'll just say place grass. All right. Or maybe it'll be render grass or something. You just, this could be done in a while loop if you're in some game logic and drawing or something, but it just depends. For now, we're just going to place grass and get a sample of it. And yeah, that's always the trouble with these tutorials is people have different experiences, we'll say, with their code. So sometimes people have a little trouble adapting one pattern to what they're really doing. And I try to branch that a little bit, or cover that, bridge that, I guess. I try to bridge that, and it's often very hard, and it basically makes me think in a way that often, once again, becomes confusing because I'm trying to go too broad. So I don't know what I'm getting to other than we're going to keep it simple, but I also want you to know that this is just a simple, goofy example. In reality, it could always be in a lot of scenarios. This isn't the only way to do it, right? All right. But the concept of reusing an object and not reinstantiating, that's the big thing with this pattern. If that all makes sense to you already, you're probably good. But if you're still a little confused, I'll show you. Okay, so say we want to place grass at ij. That simple. Now, when we place this grass, how does this function work? That's where it's going to come in. It's the exact same function. We could assume to start, the grass is all exactly the same. So anytime we call this function, we don't want to recreate the grass and then do it yet again. So let's make a flyweight of it. We're going to add a new file, call it, we'll just call it grass placer flyweight. Put the word flyweight in there, although you don't actually normally do that in code or in your project. It's just because this is an example. So let's make our place grass function, and it takes int ij. All right, and what else? How else could we improve this? Well, there's a ton of things we can do. But let's just actually place grass. We'll just see out it for now because we don't have any form of display other than a terminal. So I guess we gotta put things in the terminal to show that it's working. But if you have something else, of course you adapt it how you need to. It helps to have quotations around your code of strings. I guess this would be characters. Okay, so now we just need to think of an object here that is actually the grass. There's no object, just a cout, right? Include IO string. So it actually makes a little more sense when you have some object you're referencing. In theory, this would be referencing a block of the grass. So it would be something like this. And maybe it has a location of X and Y. We'll just call it loc2, and we'll initialize that to 0, 0. As we're assuming a 2D world just for simplicity's sake. So this would be like the overhead, grass overhead, because the actual details of the grass, where it's located in memory, we don't necessarily need to reuse that, but we could apply properties to, say, a shader, or to say how it's drawn to your graphics layer, and all that really needs is a a model view, or a model matrix rather. So the overhead would be the model matrix. Sure, you're going to need a bunch of different model matrices for where they all are located. We're just, in this case, going to represent that as slope 2 for an X and Y. But the actual grass itself, you don't need to reinstantiate. And maybe you have some other things like color or gradient that you use as an overhead, but that would be the overhead per item. So if you have that many in the world, the only thing you need is this overhead. You wouldn't actually need a bunch of the grasses, because this would be like this would be like the grass instantiation here. So it would look something like, well, let's make it static so it only implements once. It's gonna like this code, but we'll have something like an unsigned int draw location and like unsigned int, or I don't know, this is just, I'm assuming, OpenGL stuff, like number of elements. So that's, once this is uploaded, then you don't need to re-upload it, and that's what you're careful about. And this would be like code to upload your model details to graphics memory, presumably. So I could put this, for example, in my engine, and this is how I would do it if I had a grass class, is I would basically just do something like this. Upload, I guess delete is a keyword I can't use here because the keyword will just capitalize it. And since this is static and it's already instantiated, this should instantiate when we start the program. Let's be sure to put like pragma once here, or include pragma. And then let's delete code to remove from graphics memory. And when we do this, we need some sort of flag to say it's already instantiated. Like, well, draw location is 0. We know that's invalid. So we would say something. We could just do something like this. If draw loc is not equal, if it equals 0, then do the upload. Autocorrect, you only help me when they actually need you or don't need you. I don't know. And for the delete, we only want to run that if draw location is not equal to 0, means it's set. So this way, you'd only have to instantiate it once, and then when you go to draw it, this is already done. Doesn't matter how many times you need to render this grass, you don't need to go instantiate it again. And that's essentially the flyweight, is that part of it, the part that you don't need to instantiate again. The only thing you're going to need to instantiate is a bunch of locations, which is way cheaper than doing this upload and managing that. Of course, it's going to be more, and it depends on the number of, who knows how many elements it has, how many triangles. Well, I guess grass isn't going to be huge, but it'll add up once you make a bunch of them. However, you don't need to store every single one of those. You just need to store it once and reuse it. So I feel like I'm beating a dead horse with this concept, so I hope that makes sense. But let's do the example to be super sure that it's making sense. Go back to our main real quick, and let's just make a vector. Let's do something like this. Okay, so instead of place grass, let's make grass locations. So let's do a global now. So just pretend that this is the main front end for your game or whatever. We'll make a standard vector of okay, now we're going to get a little complicated with this location 2. We need to like type def that, right? Type def grass overhead, or, well, this isn't as easy in C++ as it is in other languages, because you can't just go like int 2. It just doesn't work, because you can't have it over here. You got to have it after the variable name. So we have to come up with a bit of a different solution, and we could just use a pair, or we could put more code in front of this to make it even more robust, or we could use the GLM library and use their vec2. But essentially, we need a vec2 to be a pointer of two elements, just so that we can put it in this vector. So it's actually, you know, this gets complicated real quickly. It'd actually just be easier. I'm kind of going over some maybe different thought processes you could have, but essentially you just want to split it in a struct. It'd be easier to go about this way. We could just literally use this grass overhead and put it right there in that vector. Of course, we need to include the header, so I'm talking about grass placer flyweight vector of grass overhead, and we'll call it grasses. That's a weird word to say, grasses. All right, and we'll just do grasses dot, push back. And well, we need our object, which is grass overhead dot x and y, right? So we're gonna need to put one of those. That's our overhead. We'll just call it temp, and we'll instantiate it with I and J. So that shortcut should work in older versions of C++. You might not be able to instantiate it so easily like that, but it should be fine here. And then we'll push back temp. So we run that a bunch of times, and we get all our grass locations 0 through 10 on the X and Y's. And then when we go to draw, say running, so while running, we might do something like, I don't know, for example, graphics layer draw. And it would be, I don't know, maybe we have I guess in reality, this would have the draw, it'd be something like this. So you use draw, pass in this. Of course, you'd want to do this as a const reference to make it a little more efficient. So, and some of these others could be improved too, probably. I'm kind of overlooking a lot of it, but it's a little more important once you get to draw, because this is going to be ran a ton every frame, right? So you definitely want to make this one as efficient as possible. And so then we just use this instant, grass instant draw. And then we need the grass overhead. So we would basically go through this and draw it, each one. And we can use some recent C++ features to just const auto this and go through each grasses. Well, each grass and grasses. Hope you guys actually enjoy these code from scratch versions. Hopefully it helps it click better than just reading a web page. But we'll go over an example after this off of some web page and just walk through it and do some analyzing and just see what we think. But for now, let's finish our grass. We're pretty much done. I've already gone through the concepts. Just want to finish up the code for now, or at least temporary code. So the draw is, we're just going to say grass at or something for now. And this would be tails.x, tails.y. But what you'd really do here is you would set, what you would really do in a render be set shader with details, run draw on the grass. So that's what you would really do. But instead, we're just going to say grass at to, okay, let's go back here. What do we need? We need to put grass in here. There we go. This grass instant not being seen. Yeah, I guess not. So it might not, I might be doing something syntactically wrong here with the static struct like that. But we can do it like this, and this is fine. As long as we don't multi-include this header, should be fine. So we essentially have this one class that's already instantiated, but we do need to make sure it gets uploaded. And that's something you'd have to handle. So you might want to do that before that. You would just go like grass instant dot upload. It might be like an init in this case. Upload's just one way of saying it. I guess let's change this to init, and that should do. Maybe this would be like, instead of delete, deinit or whatever you call it, just call it deinit to deinitialize. So it would look something more like this. There you go. So as you can see, as with the core, we could, doesn't necessarily matter what order you do these in. It also doesn't necessarily need to be global. But this could all be moved down here and it'd be fine. Well, got to declare this vector before we start filling it out though. That's one thing. So however you want to do that, wherever you want to put that, but this code would all need to happen before we start our loop. So the core concept here is basically that we only init this grass once, but yet we draw it a whole bunch of times. And the only thing we replicate is the things that are actually different, not this core code. So use that as you may for terrain. That's where it's generally used. Where you commonly see it as an obvious example is just terrain in games with repeating stuff. And of course they don't have one, they might have like 5 different instances, but even still with 5 you can randomly place them and still get some variety, and it will look like a lot more than 5 different ones, or feel like a lot more. So there you go. Hope that makes sense. We should be able to run this code now. And let me put a few more little just things in here to make it a little clear. All right, there we go. Got a little bit of additional comments in there so people might understand if they're just browsing and find this code somehow. Okay, so we'll say grass is init, and then we will also do an ever important thing of making this draw location no longer 0. So it would actually be whatever, it would be like a VAO, is what you usually call them, a vertex array object. But we're just going to set it to 1 for now. And your graphics layer would determine all that and how many elements, that's just how many triangles basically. This would also be set to whatever properly by the init, but we're not even using it, so I'm just going to kind of ignore it. Actually, I'm just going to even delete it to make it more simple. but that's something you typically use too when you're uploading models. All right, so grass init, and so the else would be like already init. Don't do it again, but we're just going to leave that off. But essentially, we want this guard to make sure we don't initialize it. And same thing here. I would set it back to 0 and grass init. And I'll put this same similar code. We don't need this plate grass. That was just my sample starting point. But there you go. I think we've done enough here. Let's give it a run. Let me make sure all the CMakes are fixed up. I think I need to add Flyweight here, and then we should see it show up. Helps to spell correctly. All right, there it goes. Okay, and once the CMake generation finishes, we should see it in our list here. If you're using CMake, just follow standard CMake procedures. You'll see this executable in your out after the build. But of course, in case it's not obvious, I'm using Visual Studio's built-in CMake stuff to help out and kind of reduce the amount of terminal code we need to type, but it's essentially doing it in the background. All right, so let's run our Flyweight, make sure we get what we expect. Looks like we have a few warnings. I just spelled some things incorrectly, not a big deal. Okay, let's try it again. Oh, this grass overhead needs to be before the grass, or else it doesn't understand what it is. And also, of course, this would have more. This would have like RGB color, you know, a lot more. I'm just keeping it real simple. Just want to reiterate that. We are missing a few things here. What are we missing? Oh, okay. Yeah, just need to correct some code here. I believe it's this one. Just gotta make sure we spell these right. And this grass instant is just a dot. All right. So there we go. Now it should work. There we go. We got grass init, and we should get at some point, oh, it's going to infinitely run here. So that's a little confusing. But when it calls this draw, it should be spitting out something. Yeah, it should be spitting out this grass drawn at. But it seems to be getting stuck in the init. Let's take a look. Wow, what's going on? Oh, this code right here. This should be a J. It's just staying stuck in this loop. All right, J's, I's. Yep. All right. And there we go. It's this is where it's drawing the grass, and rather than displaying it on a screen, we're just putting the location on a console. All right, now let's go Google a few examples and see what they have online, just to see how you might see it other examples. We're over at refactoring.guru. They seem to have pretty good versions of a lot of these. So if you get stuck, highly recommend reading through their articles. Also known as cache. That sounds about right. So here is the, we'll just read their quick intent section because I think this summarizes it very good. Flyweight is a structural design pattern that lets you fit more objects into the available amount of RAM by sharing common parts of state between multiple objects instead of keeping all the data in each object. There we go. I feel like that's pretty straightforward. And it looks like they got some examples of it here. Let's see what we can find. I want to find some code. There's some pseudocode. Here we go. Let's look at the pseudocode. So we got a class of a tree type. And it's got a name, color, texture, and constructor, and a draw. All right, and we got a tree factory that has some static fields. So this one is probably going to be the Flyweight. These static fields. We got tree types, all the different types. Got get tree type, you pass in a color, texture, name, color, and texture, and it creates it and returns the type. And looks like it also adds it. And then we got just a class of tree, which has an X and Y, probably for location, kind of like we were doing. And it has a very similar draw, kind of like we were doing too. I didn't look at this example before my example. I swear it's just coincidence. But, you know, in a 3D world, this would be X, Y, Z. So keep that in mind. All right, and then we got forest, which has a bunch of different trees, and it's got they made a method of plant trees that uses the plant or the tree factory to make a bunch, and then draw a bunch. So some of these things you can see are not going to be reinstantiated. Mainly, once as this adds tree types, it's only setting up a name, a color, and texture. It's not redoing this whole canvas and all of that, because essentially, they don't really say it here, but this color and texture are going to be sent to the shader or whatever's determining the draw, which is going to be a whole separate process. But the making of the trees. Now there's something here that actually is a little confusing to me that I don't, oh, I see. It's find. Here, okay, this is really important. This is what I was looking for that I missed over. This find right here checks if the tree already exists, okay? Very important. So we would assume that find is null if it doesn't already exist. So when you factory a tree and give it a name, color, and texture, if it already is found, then we just return the type. If it's not found, we're going to add it and then return the type. So essentially, as we add trees, we're going to develop a whole bunch of them. But if it tries to do the same one twice, it will just not. It'll just skip that with this here and not make a new tree, and instead reuse whatever it found. So that's where the flyweight comes in, right there on the tree factory. So that's pretty cool. I like that example. I do something very similar in some of my code on Archer Engine for a lot of the graphic stuff. So it's very useful in that area. All right, well, hope you guys enjoyed the video. Don't forget to like, comment, subscribe. If you want to go the extra mile, you can drop a donation or something somewhere, or sign up on one of the pages. I have a Patreon with all kinds of tiers. There's some stuff here on YouTube. I do have a Discord. You can find links to all of this stuff over on my YouTube main page. So if you click on my little Code Tech and Tutorials logo somewhere, you should get to that. I appreciate all of you guys that support and help out. It really does mean a lot, and it does help me keep going. I'll see you guys in the next episode, and this code will be up on GitHub, link below too. Peace out, guys.